Cool. Hey everyone, this is Sibe from Dora Hacks. Thank you all for joining us today for the applicant demo session of the Dora Hacks Space Resources and Exploration Grant. Today we have Nikhil with us to present the demo for OrbitAlD. OrbitAlD is developing in-orbit refueling for satellite life extension and plans to build a fuel station in space. So we are very much excited for this demo today. But before we kickstart the session, let me just quickly introduce about who we are and just give you guys a general overview of the grant's background. So those of you who don't know Dora Hacks, we are a global hackathon organizer and one of the most active developer incentive platforms. We love to support innovation in blockchain, quantum computing, space tech, and more. And we provide a wide range of toolkits to help developers around the world to team up and fund their ideas and projects via hackathons, grants, bounties, etc. And as we're very much committed to supporting innovators in this exciting frontier of space tech, this Space Resources and Exploration Grant is definitely going to be a long-term focus for us at Dora Hacks. And it's actually open to submissions all year round. So you can submit your project at any time. We've already concluded 2 rounds previously supporting some really great projects. You can check them out on the grant page. The link should be in the description. So yeah, we love to call all the space engineers and enthusiasts out there to join us. And we can't wait to review all your submissions. Lastly, for the audience, during the demo session, feel free to share any questions you may have in the YouTube chat room, and I will make sure to ask the OrbitAlD team your questions at the end. Now, without further ado, I'm happy to pass the mic to Nikhil. Welcome, and feel free to kick it off by giving us a brief introduction about yourself before diving into the demo session.
Sure. Thank you, Shibe. And thank you for the opportunity from Dora Hacks for presenting about our company. So as she introduced me, I'm Nikhil from, and I'm a COO in OrbitAlD. We are an Indian-based company incubated in one of the top institutes in India, and we are a space tech company. So let me just start off by introducing what our idea is. So if everything is okay, I can start. I hope it's okay, Shibe.
I guess it's still loading. It's loading now. Yeah, now it's perfect.
Great. So yeah, so we are OrbitAlD, and we are here to build fuel stations in space. So one could ask, why do you need a fuel station in space? So let us imagine a situation. You have a car right out of the dealership, and you are only allowed to use the car until the fuel runs out, and you have to then throw it into a junkyard. It's a very irrational and ridiculous way to operate things. But unfortunately, satellites are operated with the same concept. So they have a fixed amount of fuel during launch, and after they launch, they are thrown into, after the fuel runs out, they're thrown into something called as a junkyard orbit. And this, of course, contributes to the space debris problem that you keep hearing these days. So a statistic that shows us that almost 200 really operational satellites, which could have been used quite longer, worth about $100 billion, had to be destroyed just because of fuel depletion. One could imagine the magnitude and the scale of the financial and the resource issue here. So, as I said earlier, satellites are designed for one-time use, and if you really want to access the fuel port currently, you really need a lot of specialized tools on a robotic arm to access a satellite and open the fuel valve, which is a very high risk-taking maneuver, and which has only been performed maybe once or twice with an investment investment that is also equally eye-watering. The consequences of such a problem is you cannot carry enough payload because you're forced to carry enough fuel to last as long as it's possible. And in certain satellites, say for communication satellites, for getting your internet or for other Earth observation data, you would really need the satellites to stay in orbit in their place. So depending on the life of a mission, you have to keep replacing them. And replacement of these satellites, including launch, costs a lot of money. So we come up with our solution. Our solution is to make a tanker satellite constellation. So what we do is we are trying to build mini satellites, satellites of very small scale, which only carry fuel as their payload. And what it will do is it will go and it will perform something called as a docking with a client satellite using an interface. And we have also built the interface. The interface is a is a is a mechanical valve which has two parts. One is on the client and one is on the on our satellite. And the one on the client, its only role is to accept the fuel exchange and the docking from OrbitAlD satellite. So a little bit more about the interface itself. It's called the SIDRP, which is the standard interface for docking and refueling port. It's something that we have developed and we have patented, and which will go on our tanker satellites. We have tested it for really high pressure fluid transfer, and it's also easily integrable with existing satellite design. Just to show an overview of how it happens. So you have a client in a certain orbit. We will launch our satellite, our tanker satellite, in something called as a servicer orbit that is quite close to the client orbit. And then we will transfer to the client orbit, go very close to the client, uh, mechanically dock, and then refuel and return to our servicer orbit. This completes a good cycle of sustainability and it keeps the mission running. So what does refueling bring, or what does OrbitAlD bring to the table? We enable refueling accessibility. We provide cost-effective satellite life extension, and through refueling, you can have dynamic satellite mission design, which means you could carry maybe fuel that is worth only 5 years instead of having to carry fuel worth 15 years, and have a contract with us. So you can use the satellite until the instruments stop working or if there are any other problems. In some cases, if there is enough fuel, the satellite can run up to 27 years or even more. So fuel is the main contributor to satellite to determining satellite life. We are a very capable team from India. We have over 30 years of experience altogether in propulsion system design, in guidance, navigation, and control, and in combustion. And we are supported by very capable advisors from the Indian Space Research Organization and internationally for business development through an ex-Israel Aerospace Industries scientist and a startup founder of a lot of space-related startups. So, just give a financial perspective of refueling, we can consider the case study of the Alias satellite. So, the Alias satellite's mission was to understand or acquire wind patterns, and the satellite was developed at a cost of 500 million and had a mission life of 4.5 years. What we propose is we will extend the life of a satellite by 3 or 4 years, and the cost that including launch according to our financial data will cost about 15 million. So one could see the cost benefit analysis compared to the cost of development, and the cost benefit to society is 3.5 billion during this mission life. So if we extend it, we could also extend the cost benefit to society. So extending this model, we aim to serve different customer segments. So for space and defense agencies, telecom providers, space satellite operators, and a new era of space operations, which is the debris mitigation services. And in the next decade, there is going to be an exponential increase in the number of satellite launches. And according to our financial projections, we predict uh, to reach a unicorn stage if we are able to transfer 6,000 kilograms of fuel. 6,000 kilograms of fuel is actually not a lot, because an average satellite in the geostationary orbit requires 1,300 kilograms. So even if we penetrate the market by less than 1%, we are very confident of reaching these numbers. We have a few competitors. Our main direct competitor is from OrbitFab, but we are in a better position because we are cost effective, because we operate out of India, and we have a very capable space infrastructure in India as well. And looking at how the competitors have raised money, I think we are also in a good position to raise equal or even equally ambitious amounts of funding. Sorry. So this is our roadmap currently. So we have performed docking tests and fuel transfer tests on ground. The next phase of our project is to develop a facility to test in microgravity on a parabolic flight. And in 25, we are planning to launch uh, our own satellite. And this is the investment proposition that we see. So for phase one, for the pilot, we foresee we will reach a technology readiness level of 7. And of course, with our satellite launch, we will prove space flight experience. So this is a really top level overview of OrbitAlD. Please, if you have any questions, I'm willing to answer, and really looking forward to the next step of collaboration with DoraHacks. And yeah, thank you. Hello.
Oh, yeah, I'm back.
Yeah.
I do have a couple of questions for you while
Sure.
I have you here. So,
Yeah.
first of all, I'm wondering what were the main challenges you guys have faced during the past few years since you started the idea and started building and developing the projects? What were the biggest challenges, and how did you guys overcome it?
Yeah. So actually, we conceptualized the idea as early as 2015. I think there was a conceptual need of refueling in the market, because we see that it's a very, very obvious problem. But I think in the last few years, there has been an acceptance towards funding space tech startups, and that is what enabled us to grow in this environment currently. So with more interest and with more funding, I think we will be in a better position to achieve our goals. And because we believe technically we are very capable, we've done the groundwork in technically, but it's just funding and scaling up that is leaving us in a roadblock.
Got it. Yeah. My second question is I've watched the demo video from you guys. I think is mainly about the valve and the docking mechanism. And regarding your next step in 2024, like
Yeah.
what are the exact to-do items for you guys, if you can elaborate more on that.
Of course, yeah. So in 2024, what we are planning is to demonstrate the main aspects that are required in refueling on a parabolic flight. So a parabolic flight has microgravity conditions for a very short period of time, and doing the experiments in the short period of time will give us a very good understanding of how fluid transfer works in microgravity environment. So we will develop the sort of a scaled down version of the actual satellite that we are planning to send in 25, and then give us and also other investors a proof that this works in microgravity, so then we can scale up and do the actual mission.
Yeah, awesome. Sounds exciting. Please keep us updated about your guys' progress.
Sure.
So we can know more about your project's development and see how we can better support.
Great. Thank you. Looking forward to continuing our connection. Yeah. Thank you.
Sure. Let me just quickly check if there are any questions coming from the audience. Okay, I guess there are no more questions coming from the audience today. But guys, if you want to reach out to OrbitAlD team, Nikhil, if you can share the last slide for the audience, if they want to reach out, if they seek collaboration, and they can just get in touch with you guys. Feel free to reach out to the team. Yeah, perfect. Yeah, so if anyone from the audience, if you guys want to know more about the technology OrbitAlD is developing, or if you guys want to support, or if you're seeking collaboration, feel free to reach out to the guys. And yeah, I think it's a good time to wrap up if there are no more questions. So yeah, once again, a huge thank you to the OrbitAlD team, to Nikhil specifically, for joining us today and presenting this demo. Is a really good one.
Thank you.
And before we wrap up, I just want to say again that this Space Resources and Exploration Grant is a long-term initiative from DoraHacks that aims to encourage innovation in the space sector. We are very excited to have this program in place, and we already see some great projects and promising teams like OrbitAlD emerging. So we encourage everyone who's building within the space sector to join us. You can submit your project at any time, and our team will review all your submissions in a timely manner. And if you want to learn more about the grant program or just DoraHacks in general, feel free to reach out to us. You can click the link to the grant page in the description, visit our website at dorahacks.io, and we do have more space-related content prepared for you guys. So make sure to follow us on YouTube and Twitter at DoraHacks, so you won't miss out on any of the upcoming workshops and the project demo sessions we are about to host. So with that being said, I want to say a huge thank you to Nikhil again, and really appreciate it. And thank you to all the audience who's with us today. We will see you soon. Have a good one.
Thank you, Shibe. Yeah.
Thank you. Bye-bye.